All right. So today, the only thing we have left is looking at confidence intervals for a difference in proportions, which doesn't change much. Is it just you in this room?
It's alright. Join the girlies.
Who are we missing?
Kinsey.
Is she out today?
Kinsey and Dixie.
Madeline, I think we have room.
I don't have room actually.
All right. Bless you.
Thank you.
Wasn't Kinsey here earlier?
She was checked out. She was sick.
Gotcha. Again? All right. So,
Project.
remember yesterday for the 4C method of inference for confidence intervals for proportions, we talked about this. So, what's the 4 C's again? Choose, check, calculate, and conclude, right? You got to do all 4 of those on an AP exam, on a free response question. So if they just say, hey, construct a confidence interval for this thing, you need to be aware, you still need to choose, you still need to calculate, you still need to, or choose, check, calculate, and conclude. You need all 4 of them. The only time you don't is if they say, hey, assume the conditions for inference are met, and they just say calculate. The way you'll know is any confidence interval question on the AP exam will basically be, it'll just be one part and it's the entire question. If they don't expect you to do the choose, check, calculate, and conclude, it'll be like one of 3 parts. Okay, so that's how you'll know, and it's not very common, okay? So minimum N was something that, Talia, you were asking about, and so there's that 4C method. So was it number 2 or number 3 you were asking a question about?
It was, well, I found it for.
Boy.
Shut up. It was for number 2, I think I got it wrong.
Okay. So what was the N for number 2? Was it 2,401?
Yeah.
Remember anything? 2401? Is that what you got?
That's what I got. For
That's right.
No, it was the second one that I think I got wrong.
Okay. What was the sample size for the second one? Was it 2,200 something?
2002. Wait a minute.
Number 3.
Number 3. Oh, we were supposed to calculate that? I thought you were asking.
Oh, it does just say smaller or larger. I guess I actually did the calculations when I sent it out. It doesn't ask for that, but I did the actual calculations.
I got 12.25.
Yeah, I got 12 to 25.
12.25?
Yes.
It smells so bad.
Yeah.
Yes.
12.25.
Yes.
That's
You
why.
have to round it up.
B-O.
That's why
B-O.
we're literally
Yes.
going to get a plate. Look, I'm gonna get a pack of like 5.
I'm gonna
Give
get
me some water.
What we're gonna do is we're gonna have a
Oh,
school-wide conference
sorry.
on
I got
body
that
odor
wrong.
and how to manage your scent.
2401 is up here.
Yes.
Got it. This N was 1225, is that what you said?
Yeah.
Huh?
24.5.
Okay.
Also, I was right.
Yeah. Now, it is important to recognize with this, what would be the minimum sample size you would actually have to use? 1225. And I think actually, so like, it depends on how you did the calculations, but I think you had a 4-1, Raina, when you did this, okay?
5.
That's fine. Say again. You have to round up. Notice that's closer to 1224, but if you round down, your margin of error is going to be too big. You always have to round up, and so it would be 1225. I think I showed this to Raina. I don't remember if I did it on here or not. I did not. What do you mean?
Do you want me to look at my calculator?
No, I was going to put it up here. So notice if you did 1.96, actually, yeah, times the square root of 0.85 times 0.15 divided by, what was it, 1224? You see how that margin of error is just a hair too big, right? That's why you have to, oh, I'm thinking you did we were talking about the homework question when you came in.
Oh, yes.
That's what it was. Okay, but if you put 1225 in there, now it's below the margin of error that was required, right? So you always have to round up. Okay, so it doesn't matter if it's a 0.9 or even a 0.1, you always gotta round up.
Yeah.
Okay? And then in order for, if we up the confidence interval to 99%, our sample size would need to be what? Larger, because we still have to keep the margin of error to 2 percentage points. Okay, so and the idea is, remember, margin of error is equal to critical value times standard error. I want this to stay at 0.02, so if this value goes up, what does this value need to do? If I want to keep my margin of error at 0.02 and the critical value goes up for 99% confidence, what has to happen to my standard error? It has to go down to balance it out. So the sample size has to go up. Yeah.
Oh.
That's what I was trying to say. So if critical value goes up, standard error has to go down, so the sample size has to go up, is the big idea there. Okay? Yes, Madeline.
So like, I did number 1, and I like got in by itself, and then for number 2, I just kept the same, like, I knew that,
Formula stuff.
yeah, like
So
I
did you
just
calculate it by hand?
put, no, I put it in the calculator. I
Well,
moved into one side and then
Yeah.
put it in the calculator.
so what I would remind you though is, you can just do that. I'm not doing all that by hand. They don't care about you showing the work for it. If you set up the equation and then you use the calculator to solve for n, you're good. You can do that. Please feel free, but that's going to be a little bit quicker.
So what you're saying is, when critical value goes up, the sample size needs to go down?
If the critical value goes up, no, sample size has to go up. Remember, right now, what I was saying is, if the critical value goes up, to balance it out, the whole standard error has to go down. So for the standard error to go down, the sample size has to go up. That's what I was saying there. Okay. Alright, so now we're going to just transition all of this into a difference in proportions. Estimating the true difference into proportions for P1 minus P2. And so you can actually work all the way through number 3 using the information that you already have. So I'm going to give you 10 to 15 minutes, and I'll come around, I'll be supporting you, but work within your small groups. Personally, I would recommend working at a vertical surface to get up out of our desk, move around, and that way I can also just visually see right away what's happening. But work with each other to answer this question. At many high schools, the prom is an annual dance that only juniors and seniors can attend. The student council at a large high school is wondering if juniors or seniors are more likely to attend the prom. And so they take a random sample of 50 juniors and 28 are planning on attending the prom. An independent random sample of 45 seniors reveals that 29 are planning on attending. And so we want to know who is more likely, right? Yes?
Do we have a number for the population?
Do we need one?
Can you satisfy the condition?
I see what you're saying. And this is actually common on the AP exam. They say it's a large high school. So just say, since it's a large high school, we believe that 50 and 45 is going to satisfy a 10% condition. That's important because they're never going to give you a question like this on the AP exam where you're not supposed to continue. Okay. So we just say, hey, it's a large high school, we believe that's less than 1%. Which most high schools in Alabama aren't bigger than that, but around the country they are. Yes, Andrew?
I understand that we have to fulfill the 10% condition.
Yeah.
But can you give me like a couple sentences, like explaining to me what the 10%?
Well, does it ask for the proportion of success, or does it ask for the number of successes? It just says successes. So hold on to that. We're about to talk about it. Hey guys, right here, up through this point, what questions do you have? Yes, Emerson. So remember, what confidence level did we say we wanted? 95%, right? And so I'm going to go ahead and show you this so that you don't have to stress about it later. But remember, that means 95% is here, right? So what's inside of this tail and inside of this tail?
2.5%.
2.5% or 0.025. Use inverse normal to find your critical value with that tail. Okay? Yes?
Why doesn't that follow the empirical rule?
So the empirical rule is just an estimate. That's the best way I can explain it. The empirical rule is not very precise. It's a quick way to get it. So notice it's really close to 2, but it's not exact. Okay? All right, if I can grab y'all's attention really quickly, actually, so it doesn't seem like we have any more questions at this point. There's 2 things that I want to point out. You got to plug into that formula, but, and I'll print a copy of this out for you. No, that's not what I want. Here we go. Alright, so at the beginning, now hold on, you don't need to use the automatic solve, at least for where I'm thinking about, but eyes up here. So on the beginning of the AP test, you usually have a formula sheet. Last year they didn't unless they did the makeup, but I think they're going to give physical copies of the formula sheet again. But remember, on your in AP Classroom, you can access the formula sheet under references. So Raina, Lorelai, hold on a second. Okay, right up here. Need y'all to pay attention to something. Okay, so I've shown you all how to get your critical values for the 2 different confidence, or for different confidence levels on a calculator or on Desmos. But this is one of the few times that your tables are actually really beneficial. After the formula sheet, or after the test, or the back end of the test, they have a bunch of tables somewhere, maybe. Alright, so this is the table. Notice this is a z-score table. On the outside is the z-scores, and then the area to the left of that z-score. That's a useless table. You got a calculator for that. Okay? But if you go further, there is this thing called a t-distribution critical value. We haven't studied t yet. That will be next unit. Okay? But, scrolling down, notice how at the top it talks about a tail probability. And down here, what does it say? A confidence level. Now, all of these things up here are all about t. If you look down here at the bottom where it says infinity, and then compare it to the confidence level, what was the z-score for a 95% confidence level?
1.96.
You mean the same as this 1.96 right here?
Yes.
Okay, 99% confidence level, I think it was a critical value 2.576. Yep. 90% I think was 1.645. The limitation of this table and why I didn't show it to you originally is, what if you have a confidence level that's not one of those numbers? Then you don't know how to do it. However, if you know how to use the calculator, you can find your critical value for any confidence level, right? So this would help me with 97%. But I could do that on the calculator. I could do that in Desmos. So please note, if you're struggling with those critical values, it's right there. Okay? So I'll print out this table only for you. It's the only table that I recommend looking at. But yeah, there's a 95% confidence level. The critical value is 1.96. Yes,
I
Raina?
have 2 questions. So, is it possible to have, for an interval, to have a negative value of this one?
Yes.
And,
We'll talk about that in a second.
is there a reason that, without using the thing that you just told us, go to interval, you plug this up and you automatically...
We're about to talk about that. If you're talking about that, just hold on a second. All right. So that's my point. Now, up to this point, I've plugged everything into my formula, right? I did my general formula right off of the formula sheet. I went to the formula sheet on the back side. I put my statistic here, the z-score, and then I pulled my standard error straight from the formula sheet. Notice I did use S and J, right, when I did this. The reason why I did S and J was, or J for junior, S for senior. One thing I do want to point out, if I were you, this is an easy thing to help make sure that there's no confusion or ambiguity with readers. Notice when I said the true difference in proportion of juniors and seniors, I also wrote piece of J minus piece of S right after that to clarify it. I could have also put it at the front, but I always write this in there to make sure it is super clear what I'm referring to. That way if it's P1 minus P2 or something like that, it's also clear, okay? Yes, Ian?
Can you,
No. What?
can you, talk about again, like, the different procedures?
Just know that there's two populations.
Right.
Well, I mean, like, I know there's one and two, like, where the ones that come after.
What do you mean the ones that come after? Like what comes after it?
Are there, like, 4 different ones?
Yeah.
There's only,
Sample or proportion. I don't understand sample.
We just did this.
what do you mean?
We don't, we
Like
didn't
one
do sample.
interval, Z, one, sample.
Are you talking about from like AP Classroom stuff?
Well, yes.
You're talking about the questions from AP Classroom?
Yeah.
Did they make something up to confuse us?
Correct.
Oh my gosh.
Oh.
Oh,
So
yeah.
trashy.
I know.
Alright, I gotta be quick about
Don't
this.
call me that.
I mean, you are what you are though.
How many questions did you
That was B.
You're what?
I'll be great.
So, like, no, something like that.
This is the wording so confusing. Sample report, population proportion.
Okay, so let me pull up the progress check really quickly.
Sometimes I don't wanna be happy.
Oh my god.
Is that- is that-
Have you got this far? Is it when this was getting the calculator?
It was just progress check A, right?
Yes.
Yes.
I look-y bombed
And I think it was the very first one, or first couple.
Yes.
So right here. So yeah, right here, a one sample Z interval for a sample proportion, it doesn't exist.
Okay. So what?
Because we don't need an interval for a sample proportion, we calculated a sample proportion.
Oh, that's how I put it, that's what I put.
But we already know the sample proportion, we're doing an interval for a population proportion. Now, a one sample Z interval for a difference between population proportions. Can you have a difference between population proportions with a single sample?
No.
No. So that also does not exist. Bottom one's here, a two sample Z interval for a difference between,
Sample.
I don't need an interval for a difference in proportions. I only, or I don't need an interval for a difference in sample proportions.
Oh, because you already have the same.
Because you already have the samples. Yeah.
I know.
It's all about the population proportions.
Not read that.
Yep.
Why is E
So-
wrong?
Why is what?
E.
Because if you go back up and look, there's only one sample,
Oh, yeah.
right? I'm not looking at two different samples. Okay.
What do
So,
y'all know? Oh,
All that to say, you're overstressing it. We had two samples, right?
Yeah.
It's a Z interval, and we're looking at a difference in proportions, population proportions. That's it. It is what it is. Yes.
Okay, so you said like to keep the reader from getting confused, you did like the little extra thing. What if you put like a P hat over that?
That'd be very wrong.
If it's not required,
So it's a.
will they'll still count?
So, you will actually, if you put a P hat here and here, that will drop you from an E to a P on this section.
So,
Because what is this what is this? This is a parameter, so it has to be a parameter. P hat is a sample or a statistic, right? So be careful when we're defining our parameter, it's gotta be a parameter. It's gotta be a mu, not an X bar. It's gotta be a P, not a P hat. It's gotta be a sigma, lowercase sigma, not an S. Yes,
is it because we're trying to estimate
right.
the parameter?
You don't have to estimate a sample. You're estimating a parameter. Right. Okay? Now, for all of you that were stressing and trying to type out this formula into your calculator, you're making your life hard.
No.
All you gotta do is write out the formula. Now everybody pick up a calculator.
The interval two proportion.
Hey,
I can get there.
Wait, I didn't realize.
Okay? So what's the button that makes my life easy? Menu. Okay? What are we studying?
Statistics.
Statistics. What are we trying to calculate? Look under confidence intervals. If you took the time to choose your procedure correctly, then you should recognize I have two proportions and I'm looking for a z interval. Notice how this says x, it doesn't say he had, it says x, which is a number of successes. So for the juniors, we had 28 successes. What was the sample size? 50.
Oh my god.
How many successes did we have for the seniors? 29, 45,
And it's automatically.
and a confidence level of 95%.
What does that mean?
Oh my god.
There's my interval.
Wait,
Yes.
so since Raina put in the fraction, it was like less than one.
It was
Yeah.
there, it didn't even let me solve.
So that's why, like, you have to put in successes, not those things. I would point this out, something to think about. No, that I lied. Don't do that. All right, ignore what I was going to say. At this point, we need to recognize that the interval itself, the last step. So I've plugged everything into the formula. What is my interval?
Negative 0.286.
0.1117.
Okay. So this is where the interpretation can get tricky if you haven't taken the time to define your parameter from the beginning. But if you've defined your parameter from the beginning, you're set here. There's my interval. Okay. Yes, Rand.
So, first, I didn't know, obviously I didn't know how to do that. So I plugged the thing every single time to do, and I got the value, but it's a little.
Rand, we don't care about being off by 1,000th of a decimal.
Like hundreds?
That's not that big a deal. If it was a full 10th off, that'd be different. Okay. All right. We've got to interpret this interval at this point. So how do we start by interpreting an interval?
We are 95% confident.
Okay, so with
With
95% confidence.
The interval
The
from.
interval. So hold on. The interval
Well, I mean, this is like
from
negative
-0.2806 to 0.1117 captures what?
The true proportion of different
Okay.
values.
Notice at this point, this is why I said earlier, if you've taken the time to define your parameter earlier in the choose, you just take that parameter and you write it right here. That's it. So y'all are all right. I just want to point that out. If you've taken the time to accurately define your parameter, you're set. The true difference in proportion of juniors and seniors planning to go to prom.
Mr. Finney.
Nope. Alright, what's up?
Oh, so you said you need to include the choose procedures, confidence level, and parameter when you construct to
Yeah.
do the interval.
Yeah.
So, but you said if you did describe the parameter earlier, you can just plug that in. So does it mean that in the free response, you don't necessarily need to define the parameter in the first place?
Take the time to define the parameter in the
Okay.
first place. Just do it.
Yep, I will.
Like, it's gonna make your life easier if you take the time to do that.
Okay.
Okay. But please notice, once again, you got a formula sheet. Put in that formula sheet. Or put in your formulas. Go general, specific, substitute in, calculator. Yes, Sophie.
Why don't we include population proportion?
Oh, I see what you're saying. You can, but remember this word true automatically implies population. So the true difference in population proportions is completely good. I almost even wrote it in there, but by saying true, I've covered that idea. Yes, Andrew. You You know that we're dealing with proportions, right?
After many.
So you have to do two proportion.
So what do we?
Well, there's proportions and then there's what?
Oh, are we gonna have 5 samples or something?
No. We have proportions that we try to estimate. What else are we gonna try to estimate?
12.
Hey guys, really quickly, I need y'all to think about this. The reason why we're doing two proportion here, not two sample, because two proportion is for proportions. What do you think two sample would be for?
Two samples.
Two sample
Lean.
means.
Mean.
Right, when we do two samples, we're talking about means. What did you say, Tina? Yes, sample it for the means. Yeah, that's what you
So
said.
are we
But
doing that in the next unit?
that is the next unit.
That's so Paul goes.
Okay. So, I do want to quickly show you Desmos. It's actually really easy for all this. So if I go to functions and I scroll down to inference, notice it's again going to be a Z prop test, which you can't really see. Let me scroll down. You're going to want to click Z prop test, and it only says successes and sample size, but I actually have to put in both sets of samples. So 28 is the first one with a sample size of 50, comma 29, comma 45. So you have to put in both samples here. Then you do a confidence interval. And does that confidence interval look familiar? Yeah. Negative 0.281 to 0.112.
Desmos is superior.
So there's all that. I don't agree with that assessment. All right, number 3. So this is what the last thing. This is important. Actually, really quickly, because we only have a minute left. I'm going to give y'all an option. We can either, after lunch, take the DYU right away, or just go ahead and start the next half, which is about hypothesis testing, and then start tomorrow with the DYU.
Why would anyone?
Raise your hand if you want DYU tomorrow. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 8 out of 12 of us, that means DYU is going to start tomorrow. So we are going to start the next half of the unit. Now, the next half of the unit is all about what's called hypothesis testing. Will that be on your DYU tomorrow?
Yes.
No. No hypothesis testing. It is only going through this lesson.
Is that on the?
Does it mean that this part doesn't deserve to be included on the DYU tomorrow?
Yes, what we just learned is on the DYU. But hypothesis testing is not. Star. Don't say dumb things. It's not on the AP test? Yes, it's on the AP test. That's why I'm teaching it. Yes, that is progress check. So here's the thing. This is what's really important with these confidence intervals. So, does the interval provide convincing evidence that juniors have a lower proportion planning on going to the prom, or is it plausible? Notice that keyword plausible again. There is no difference between the two classes. Charlie, what do you think?
Most of those hypotheses will be calculated will include both negative values and 0.
And so which of those is the priority?
I suppose
Remember, the question is that there is no difference, right? If there is no difference, what does this equal? 0. So is it plausible that there is no difference? 100%. That's what we need to pay attention to. If it was all negative, what would that tell us?
It's lower.
It is lower, but like, who's more likely to go to prom?
Nobody.
Seniors, right? That means my second value is a larger value. This would be convincing evidence that seniors plan to go at a higher rate. If this was the interval, this would be convincing evidence of what?
Juniors.
Of juniors planning on going at a higher rate. What? Because that would mean that the juniors have a bigger value.
I thought you were writing the proportion of those.
You thought what?
I thought you were writing like proportion numbers that we had.
Oh, no. P. That's the interval. Imagining that's the interval. Okay? So, do we have convincing evidence there is no difference? Or no, what did it say? is it plausible that there is no difference?
Yes.
So is there convincing evidence they have a lower proportion, or is it plausible? So looking at number 3,
The difference of 1 and negative 1 constant.
because it is plausible, not possible, but plausible, it is believable that P sub j minus P sub s equals 0. No, wait. Yeah, because it's plausible that this is true, there could be no difference.
Is it not really added?
Well, remember, we already know what P hat is, right? This interval that we just calculated, right, the interval of negative 0.2806 to 0.1117, these are the plausible values for what?
It is for difference of junior number and proportion of juniors and seniors.
Which proportion though?
Difference in P sub j.
Is it P hat or is it P?
No, P.
It's P. Guys, you gotta remember, we already knew what P hat J minus P hat S was from the very beginning. It was 0.08. What was next?
The 4.
4 repeating, okay. Notice we already had the sample. We already know what the sample is. The interval is always about the what? The population. We already know the sample. It is plausible that the true difference, remember that was our parameter from the beginning, it is plausible that the true difference equals 0. There could be no difference. There is not convincing evidence.
Oh.
The juniors plan on going at a lower rate. And this is something you gotta train yourself for. Notice, I didn't make that up. Where did that come from?
The interval.
It came from what?
Interval.
No. Where did this language come from? The question. Yeah. Like, literally, I just stole it from the question. You gotta be clear, you gotta be consistent with your language. So, I am addressing, there could be no difference. There is not convincing evidence that juniors plan on going at a lower rate. Charlie first, then Madeline, then Raina.
If there's simply convincing evidence,
Say that one more time.
if there's simply convincing evidence that all the values are positive, or values are negative.
So there is convincing evidence when all the plausible differences are negative or all the plausible values are positive. Yeah. Because remember, the whole idea is right now, it's plausible that the difference is what? 0. That means there could be no difference. Does that mean there is no difference?
No.
No, it just means that it's
Plausible.
plausible or could be. So convincing, actually that's part of the quick notes, so I'll hold off on writing that, about the convincing evidence, okay? So I'll leave that up there for a second for you to write down. Nope.
Yes, ask your question.
Yeah, what's the question?
I mean, you said no.
Raina,
Hey,
how long have you had me as
no,
a teacher?
no only means no.
Raina, don't let them silence
Raina, what's your
I
question?
don't want to be polite, right? Anyway, so.
I do not want your teeth.
It's your fault, it's
Get
just, and you're
away.
coming out
You're
stressed out.
so weird. And you're
So do, in the future FRT that is something like this, do we need to include that it has plausible evidence that it's the difference?
Only if they ask.
Because of explaining why. it's
This, if they say construct a 95% confidence interval, choose, check, calculate, conclude is what you have to do. They could ask that at the end.
Okay, do we need to explain that part, like, because it's not all.
I'm about to put that in the quick notes.
Okay.
Yep. What, was there another question?
I raised my hand. I think that's what you're trying to.
Okay. Alright, we gotta do our quick notes quickly and we gotta start the next lesson. So,
Please put your socks on. Please put your socks on. Okay, because you want to say I'm sneaking, I don't. The first response is take off your socks and
listen, all I know is if they do stink, we'll know in about like 2 seconds. We'll probably be like, that's great.
Okay.
I smell all the way across the room.
It's not my fault that your room just always stinks.
Here's
Because
a quick question.
because your kids smell sour.
I'm just saying, does it smell like that after you come back from lunch?
Yes.
Still?
Yeah. Half the time it smells like whatever food you put in the microwave.
I haven't even been putting any food. That's the food y'all put in the microwave. Alright,
Wow.
so 4C method of inference. What do we need to do?
Check. Choose.
Choose. Remember with your, yeah, we did do this before, but now we're doing it for a 2 sample Z interval for, I'm just going to simplify it here. You can probably actually write it this way.
Does that say method?
The 4C method for inference, yep. Make sure we add our confidence level and define the parameter here. When you choose, make sure you identify the confidence level and define your parameter. Check. What do we got to check?
Oh, the 10%.
So, how many of the samples need to be random?
All of them.
All. So, both. It is also important to note when it's 2 sample like this, not only do they need to be random, they also need to be
Independent.
independent. Yep.
10%.
Okay. So this is not the 10% independence. This is one sample is independent of the other sample. The whole combining random variables does not work unless they are independent random
We're
variables.
not calculating though, we're just seeing it if it's different by our eyes.
What?
Never mind, no, nothing.
Okay.
That was just being
Sure.
weird, yes.
All right. What's after random?
10%.
10% condition. For how many of the samples? For both. Do you actually need to show the checking and write out and go beyond just saying 10% and check?
Yes.
Yes. You do not get credit on that free response portion if you just put 10% check.
Wait, what does CO mean?
Confidence level.
Okay.
And then what's the last thing?
Please check for normality.
So I like what Charlie said with it better, because it's not always going to be large counts. It is always going to be the sampling distributions are what? Approximately normal. So sampling distributions approximately normal. And how are we going to check that with proportions?
CCL. I mean LCC.
Large counts condition for proportions. What are we going to do with means?
Cheated lettuce tomatoes.
Central limit theorem, or the population is already approximately normal. Now, we're going to talk about that a little bit, because if you don't know the population, it's kind of hard to say that, but we'll talk about it. Yes?
Okay, I think you said this once before, but, for the 10% condition, if you don't know the population, you just assume it's true.
You just kind of say, it's believable that this is less than 10%. Like, we didn't know how big the high school was, but it's safe to assume 50 is less than 10% of a very large high school group of juniors.
You need to write that out.
Yes, you have to write that out.
Gross.
We all get by the
I had it written out that way earlier.
Would you say, like, will you assume this? Or,
We assume n equals 50 is less than 10% of the population. I will point out, if you actually looked at the language that I wrote up there, I actually never said the words large counts condition, and I never actually said the words 10% condition. I just checked what they actually were. So you don't have to name it, but if you name it, then it might be helpful for you. It's just up to you. You have to check those conditions, you don't have to name them. But I will say naming them is good for you. Yes, Raina?
What if the mean and the fair amount include notes about experiments?
We're gonna talk about that in a second. Okay. So calculation. Remember, I would highly write out your general formula. I would write out my specific formula. Because what you have to have for the AP exam is you have to have values substituted in. But you know what a lot of people make mistakes on? If they don't write out the formulas ahead of time, they make mistakes doing this. You have to show your values substituted into the formulas. So you don't have to have general formula and specific, but I recommend it so that you don't make mistakes. Okay? By the way, are you going to put all those values into the calculator, substitute in? No, we're going to do what?
6.
Dude, just use your eyeballs. Don't try to memorize all the buttons. 2 prop.
Is it not the button?
But it is, but like if you try to memorize all these buttons, when you could just say, oh, I want statistics, oh, I want a confidence interval, oh, and that's right, I want a 2 proportion Z interval. Then you just read what's there.
But it's easy to remember 552 for no reason, yeah.
Is it easier or is it quicker?
Quicker.
Okay, but do you know how many series of buttons you're gonna have to memorize by the end of this course?
Not
Like 6.
I hate you so much. Conclude with 95%. Now, is it always going to be 95%?
Maybe not.
No, okay. But whatever your confidence level is. So I'm just saying with 95% confidence, ... right? It's the same conclusion. It is this interval from blank to blank captures the true blank, right? The parameter, okay? Evaluating a claim.
Was that the question or?
If we have, well, that's the next learning target, okay? If we have an interval that goes from a negative to a positive, what can we conclude?
Is it green?
If it's equal, it is 0, if
Probably
it's
no
0.
It's not that there's probably no difference. It's not that it is 0. It is
Plausible.
plausible for what?
Value for 0, difference to be true.
So plausible for no difference. So does that give us convincing evidence or not convincing evidence?
Not convincing.
Not convincing. Yes, Charlie?
This will probably never happen, but what if it's like 0 plus?
Yeah, that's a good question. Technically, if it's a 0, that 0 is not included, so it would be convincing evidence because it would only be positives. Does that make sense? So that's what we call an infenum, which technically is not a minimum. An infenum is what it approaches, not necessarily what the minimum is, because if it's a parenthesis, it doesn't actually get there. Don't worry about it. It never happens. All right, what if we have a negative to a negative?
Convincing evidence.
Of what?
Of the P2 being larger than P1.
There we go.
Wait, was that one?
That was some order. I'll give you that.
Sorry, why would you guess?
Sorry, why are you?
I mean, it's true. Convincing evidence P2 is greater than P1. That's the only way we get a negative is if we subtract, right, and P2 is bigger. Okay. So what if we get a positive to a positive?
Good question. Convincing evidence that P1 is larger than P2. Yes.
Now, no, I'm putting all that down there.
Okay, I had to take a STEM break.
Okay. Yes.
What is no difference in like math?
Here we go. If there's no difference, the difference is 0. And so if we go from a negative to a positive, what number do we have to hit? 0. So that's why if it's negative to a positive, it's plausible that there's no difference.
I like when it was around 50, it's plausible.
Yes.
No.
It's just plausible. It's just, yeah, I mean, it's never going to be exactly 0, but like if it was 0.005, could we say there's essentially no difference?
Yeah.
Okay. Now, Raina, you were asking about experiments earlier. There's a really good explanation of it in the textbook, so I'm going to make sure I read that and get it properly to you. But we need to recognize here, we found that it is plausible there's no difference between the proportion of juniors and seniors who plan on going to the prom. But if we have an experiment, what clear language do we have to have?
Causation.
We have to talk about that idea of causation. There is convincing evidence that this treatment would cause this difference, okay, or would be more effective is typically what we would say. The one thing, and we'll see some examples of this, the one thing you have to be careful of language-wise, and this is why I'm going to refer you to the textbook and I'll look into the exact language again, you have to be careful that your conclusion never refers to the sample because it is about all individuals. We already know the data for the sample. So there's convincing evidence that drug A would cause a better result for all people like those in the study. Do notice I had to say like all people, or all people like those in the study, because I could not generalize to a population. And that is actually a good point as well. Would there be random selection in an experiment, or random sample in an experiment? No, but there would be random assignment. So those are small differences in experiments versus observational studies. In an experiment, you need random assignment, and in a observational study, you don't. And then again, in the conclusion, you have to talk about there would be a difference for all people like those in the study. Okay, but again, look in the textbook because I promise you it's there.
So you're saying, Karen, you need to
Please throw your trash away.
include.
Say that again.
What you're saying is in experiments you need to include the reference about population.
Well, you always need a reference about population. It's just really easy a lot of times for students to end up talking about the sample instead of the population. So you have to be careful about that. Guys. All right, we do not have time to do the check your understanding. I will send out answers for it tonight to help you prepare for the DYU tomorrow.
I think I had a question.
Well, I'll answer in a second.
Wait, if we all get 5s, can you shake your head?
What do you think my response to that question is?
Yes.
Yes.
Mr. Kenny, you've never done all 5s before.
I have never.
Yeah, you get 5, so you
Right.
should celebrate.
I would celebrate, not with shaking my head.
Wait, can you like pay us for a trip to like Hawaii?
Yeah, let me bust out that kind of money.
A noodle party.
You got it. Or at least you got it.
Would you say a noodle party?
I could dye my hair pink, I'd do that.
And your head blue.
What? Who won this
A noodle party.
I don't know about the hair blue, but I could definitely do pink, or what do you say, pink or purple for the beard? Pink for the beard, I could do that.
Wait, can we match pierce it and then?
Sure. I don't know what experiment we're running, but, alright. So, we've already finished, which I apparently forgot to update this. We've already finished the confidence intervals for proportions. What we're about to go into is what's known as a hypothesis test. Now, I'm going to go ahead and tell you this. It's interesting because hypothesis tests are almost like the gold standard in statistics. However, a confidence interval actually reveals a little bit more information. So, why do we do hypothesis tests when we have confidence intervals? Not 100% certain. Yes, what you got?
So when you said P1 minus P2, what's the 0 for?
So P1 minus P2 being less than 0 is equivalent to P2 being greater than P1. And remember, this was the negative to negative. So that would be the case where P1 minus P2 is less than 0 is when we go from a negative to a negative. And that's equivalent to P2 being greater than P1, is all I was saying there. So, all right. So, I did not print out the proficiency scales yet because I want to go back through these and I didn't have time during planning today to make sure everything is there that I need. But I do want to point out the foundation, most of this should look pretty familiar. In fact, looking at the foundation there, is there anything that is new?
No.
At least in the terms.
Stop!
Random condition.
Yeah, that's the one
No,
we
that's-
didn't talk
You said random condition?
Yeah.
I thought we had that in the last proficiency
It
scale.
was,
We didn't
I don't
talk
think we
about it.
talked about it
Oh.
last time either.
What's the random condition?
I don't know, you tell us.
It has to be random.
Yeah, the sample has to be random.
Oh, it's just like the
Oh, wait,
idea.
it's just-
Yeah, it's just the concept of the sample needs to be a random selection, a random sample. Or random assignment in an experiment.
I didn't
Yeah. Okay. But yeah, critical values, z-scores, sampling distributions, all that should look familiar. And then even in the target, which this is why I want to update this. Oh no, that's all the proficiency scales, or the confidence interval stuff. So I need to update this and put in hypothesis testing. So we'll get to that later. Alright, so we've done some of the hypothesis stuff in the past, okay? When we did the 1 in 6 wins, you remember when we looked at the likelihood, so there was a claim from some soda company that claimed 1 in 6 people would win when they took the top off of their cap? Right, Mountain Dew, okay. So we had that, but then there was the sample where this class went, and I think only 3 out of the 30 people in the class actually won. And the question was, well, could that have happened by random chance, or was something fishy going on? And we decided, I think it's actually right here. Is this the exam? Is this it? No, that was John and Jennifer. Oh, this is literally this one, right? So remember, we did a simulation, right? And we only had one person. Oh, it was 2 out of 30, I guess. We only had one person who got 2 or less wins. And so we're like, man, that sounds a little fishy to me.
Wait, was it 2?
For some reason, I have 2 marked there.
It is 2.
It was 2?
Yep.
Yeah.
Yeah.
Oh,
2 people won,
That's
okay?
like nobody got.
I don't remember what it was.
Okay. But the idea was, man, that sounds really fishy. 1 out of, how many trials did we do? 60? 1 out of 60 is a very low chance of happening by random chance alone. So now we're thinking, man, I think that
not
company
true.
lied to us, right? Well, so Ms. Kowalski was my intern in the spring. And so I rewrote this task just slightly to be based on Ms. Kowalski rather than, I don't remember, the
Oh, the greater.
Gallagher was her name, I think?
Miss
Who
Gallagher.
was that?
Is she any good at basketball?
No, who, Ms. Kowalski?
Yes.
She was tall, I don't know.
Oh,
She's taller than I am, so I was like, you know what? I'm short, no one's gonna believe me, I'm good at basketball, which you shouldn't.
No,
And,
I can see you being like weirdly.
no. I was good at cross country, and I
Oh, me
was
too.
okay at basketball, and I was decent at baseball, but cross country was my jam. Alright, so anyways, so in our introduction to significance test, which we've already done that, we use simulation to estimate a p-value. That's what we did right here. Nope, right here. We even did this, if you remember, at the very beginning with Joy Milne smelling Parkinson's, right? And she got 11 out of the 12 shirts originally, but it ended up being 12 out of 12, right? And we said, man, that is so unlikely to happen by chance alone. I don't think she's guessing. we have convincing evidence that she can smell Parkinson's, right? So that's what this is all about. Ms. Kowalski claimed that she was an 80%, is this lesson 1 or 2? This is corresponding to 1?
You're on 2, I think.
No, that is definitely lesson 2. I have the wrong one pulled up.
Yeah, we know, Mr. Kenny.
I was like, that
This guy's teaching us, by the way.
Hey, did I realize it?
Yes.
Okay, he helped me.
Give me my pencil back, idiots.
What was that garbage? Here we go.
Can I please have my pencil back?
No, you don't deserve it. Okay. So what y'all have is Ms. Kowalski claims she's an 80% free throw shooter, but I doubted that, right? So to prove her skills, she took 50 free throws and made 32 shots.
Okay.
All right? So I want you to work with your small group. I want you to identify the population, the parameter, the sample, the statistic, Ms. Kowalski's claim, and my claim in the context of this problem. And then we're going to do a simulation in a little bit, okay? So we're going to test her claim in this. And I'm going to get you to number 3 in a second, but work through numbers 1 and 2 first, and then we'll come back and talk about what we're going to do for number 3.
The sample is 50.
50.
Huh? What?
You need to listen to Andrew.
What did I listen to?
No context.
Oh dear.
Oh, free throw shots.
You stop spoiling.
Y'all can actively work together.
Are you like...
It's like he hasn't been in class all year where I tell y'all to work together.
Ian, are you even in class?
Mr. Kenny, last month I ate a Rice Krispie and I put marshmallows on top of it. And
Yeah,
it
you
made
were
my head
showing-
hurt.
Hey, how's that stats going though?
I'm telling you, that's what my brain is doing.
Oh.
Time out.
Hey, what's going on?
Is there a way to simulate this on the
There sure is.
Parameter is.
What do you mean for 14 weeks left?
Well, when somewhere back in August.
I've already taught you how to.
I'm gonna just call it Mrs. K.
The parameter is the true proportion.
Are you sure you tell us something?
100%.
I wrote at first and just proportional shots and next, but.
You will in a second.
I probably will.
Hey, Ian.
I'm sorry.
Yeah.
Wait, so it's 80% not? Probably not. My bad. Probably.
Wait, she was married?
It was Miss.
I was about to type
It was Miss. I forgot to change that.
Married in college. Yeah.
That happens, Star, it's not possible.
Not impossible.
Yes, she graduated this spring.
It's married.
How do you know?
Because you just said it.
She graduated in the spring?
She was my intern in the spring.
Because Mr. Hobby was your intern in the fall.
Yeah.
Who's Hobby?
Mr. Hobby?
Mr. Hobby.
He's a dorky man.
He was. I loved him. He was fantastic. All right. So here's our population sample. Please make sure you pay attention to that context well. Okay. Notice it's not just all free throw shots. I know somebody said that earlier, but it would actually be all of Ms. Kowalski's free throw shots, right? Because I don't care about Emerson's free throw shots, at least in this case, right?
Why Emerson?
Her sample would only be her 50 free throws. Okay. What questions do you have on numbers 1 through 2? Okay.
Why did you word it so?
Why did I word it like that?
Yeah. Why did you just say 0.64?
Well, because 0.64 isn't
Oh.
what I believe about the true proportion. 0.64 was my sample. I don't necessarily believe that she can make 0.64. I just don't think she can make 0.8. I think she makes less. Please, so please notice, our claim is that she can do this thing. I doubt that. I believe it's actually less. One way to write this, and we'll practice doing this soon, is P equals 0.8 versus what? So P is less than 0.8. So, what would I call these two claims here? Something we've already learned.
Null hypothesis.
This is our null hypothesis.
Null hypothesis. And your, what, isn't that H subscript O or something?
Null is.
Ian, please stop touching me.
Well, we talked about it. So the null hypothesis, that subscript O, or 0 really, is the null. So like, you can also read it as V naught if you ever take like a physics class. That's the initial velocity, the null velocity. Okay, so what's my claim going to be called?
The opposite.
H sub A, what's that A for?
Opposing.
All.
Alternate.
Alternative.
And we do alternative hypothesis. You can say alternate. You'll just say things seen in the book is alternative hypothesis. Okay. Say again. Alternative hypothesis.
The O is
Null hypothesis.
Yeah.
H sub 0. H sub A.
0, like null.
Sub 0. Oh, sub O.
They look the same.
It is a 0 for the null. It's not O. I know it looks like an O. I will say, if you look in the book though, it's more elongated like a 0.
Okay.
Alright, yes,
Are
right.
we still talking about proportions on B, right?
The best one.
On number 2, we're still talking about proportions, yeah. That was what our parameter was, right?
Yes.
Okay, so to test our claim, we're going to assume, number 1, that she can make 80% of her free throws, and examine the probability that she only makes 32 out of 50 purely by now. Charlie and Ethan were very concerned that I haven't taught y'all how to do this simulation yet.
I never put hand right.
I know. You're like, I don't remember, it's fine. Ethan said that I had never taught it. It's okay. He doubted me 100%. But here's the thing. So I will say on the calculator, no, there's not a simulation button. But what do we have available to us that could simulate randomness?
iPad.
The what? Oh yeah, we have a random number generator, right?
I can't let it go. I can't.
What?
You did this earlier, and I just can't let it go.
Yeah.
What does that mean?
At least you're locked in-ish. All right. So, what are we going to do on the calculator to simulate this case?
You do number 5.
No.
Wait, I mean you go to menu. You go to menu.
Okay, so I'm going to go to menu.
Number 5 4 random.
So we need random. If you go to number 6, there's not a random option. Number 5, there is a random option.
Right.
And then random what?
Number.
I'm going to do random integer. Okay? So we want random integers. Now, what random integers do I want to generate to test her ability to make 80% of her free throws?
1 and 2.
Now, if I do 1 and 2, either she makes it or she doesn't. That's going to be, give me what possible percentages? 50%, but we said she's an 80% free throw shooter.
You have a 5.
1 through 4, so like if we assign like 1 as she makes it, and 2, 3, 4 she misses, that's only going to give me up 1 to 25%. Say again?
We can do 10 and 1 through 8.
So we could do 1 to 10, and 1 through 8 is a success, so that's 8 out of 10. That could work. Or I could do 1 through 5, and 1 through 4 would be a success. Or I could do 1 to 100, and 1 through 80 is a success. Just for kicks and, not for kicks and giggles, for me, I'm going to do 1 to 10, and that's going to be a success. Now, if I hit enter right now, that's only going to generate 1, and we need to generate how many?
50. So
You
comma
have to put another comma.
I put another comma, but here's the thing. just pause for a second. If you put 50 here, like,
We're not reading.
you gotta read all that, okay? Instead of that, what I might do is sets of 10,
Okay.
because you can do sets of 10 pretty easily. Now, I would, if I were you, randomly seed your calculators first. Is that what you're gonna ask, Madeline? Yeah. Just in case, I would randomly seed my calculators first. Yes?
What function I found random binomial?
Say again.
What function I found random?
Yeah, I know
binomial?
that's
I'll show you
what does it do?
Under random generation. I don't know that one well. I'll have to look at it. All I would do though is on this, so like for me, I'm just gonna count what doesn't win. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got 39 out of 50. So you need to find 3 samples before class ends. So notice all I did was but look, I just did 1 to 10, I did 10 5 times, right? And then find your proportion of successes. Now, what Charlie actually watched me do is I actually found my failures, which told me my number of successes. I had 11 failures, which meant I had 39 successes.
Wow.
So I counted my 9s and 10s.
I'm gonna do that.
I'm not.
So it's a random binomial distribution. That could speed things up. The only thing I will say is I like doing this because they will expect you to be able to do that on the AP exam.
So I'm going to click to see what you know.
Well, you wouldn't do random seed with the random integer. Just put in a random string of numbers. Hit enter. Now you can do this. There you go. And there's your 50. Your first sample of 50. Yes.
How do I like a copy of this over it?
Just hit enter again.
Really? Oh, okay.
Yep. So you can do copy and paste it, but like when you're just reiterating the same thing, you just do that.
So you said 1 to 8 is a success.
That's what I said it as. You could do 1 and 2 are a failure, and 3 to 10 are a success. It's your choice. You just have to have 8 of your 10, or 80% be a success. Huh? Wait.
You just said we need 3 samples, right?
Yes. So you've done this once. Okay. So that's how many she made out of 50?
Okay.
Now you need to do that 2 more times.
What about my data points?
You already have all of yours? Well, hold on to it for a second.
Oh, yes, so.
Wait, what are you telling again? Wait, what are we? We count successes, right? So my successes are.
Dude, wake up, stand up. Stand up. You're moving, so no one can wake you up.
Hey, maybe you spread that hot breath. Maybe that's the.
Stand right here, bro. Stand up, do your freaking work.
Wait. I have a question.
Yes, ma'am.
Well, I need assistance.
Has anybody accidentally drawn on your screen?
Yeah.
I thought we were finding the answers.
But watch. All you gotta do. Yes. Well, so remember, she's an 80% free throw shooter. So what we said is we're gonna let 1 through 8 represent successes, 9 and 10 be failures. So what I did was, because we should have more successes, I counted my failures. It's a success or a failure. Alright, hey guys, really quickly, listen up. We got 75 seconds, so if I can grab your attention. If everybody in here does do 3 samples, we do have about 50-ish trials. Do this for me though, do another set of 3 so we can get more data and get a better picture before class tomorrow. So please notice it didn't take too long to get 3. Is that fair to say?
Yes.
Okay. So do 3 more samples, write those off to the side. We are going to do a dot plot like this, and then we'll pick up after the DYU. So we're going to do a DYU tomorrow to start, and then we're going to put our data up on the dot plot. Sound good?
So, yes, so.
P.S. Is any of this on the DYU tomorrow?
No.
No. Yeah, that was good. That was well played.
Let's just say I'm not.
I am.
Hey, I will point out, at this point, there is a progress check that's not a full progress check. It's the one I sent in the email. That is just 6 questions that deals with 2 proportion z intervals. I would do that. Thank you.
I am Nibble. Watch my belly.
Hey, Mr. Kenny.
Hey, Mr.
Actually,
Anderson.
never mind. Sorry to say what?
What did you say, Emerson?
Never mind.
Okay.
I hate that.
Everybody's playing
How
out.
white is he?
Ian does not need Nibble.
Rub my belly.
Wait, what's Nibble?
Because
How white is
every
he?
time I look at him,
Who is Nibble?
I blink.
Yes, I know who he is.
Pibble.
Right, listen.
No, not Pitbull.
Oh,
Pibble.
no.
Mr. Kenny, rub my belly.
Can you calculate how white I am? Because my great.
Pibble, wash my belly, rub my belly. Oh, I need this.
Wait, I have to keep.
That was funny.
6, 7.
Yes, I will.
Andrew.
Not like
Yes, I am.
I'm so good at it too.
And autism? Yeah, that's exactly what I'm
Wash, did you say wash your belly?
No, he doesn't.
No.
Wash my belly.
No. I can attest to the fact